Discover the manufacturing process technology to produce machines that generate energy from ocean waves. Wave energy is a promising source of renewable energy that can provide a sustainable and environmentally friendly alternative to conventional energy sources. One of the key technologies used to harness wave energy is wave energy machines, which convert the kinetic energy of ocean waves into electricity. In this article, we will explore the process of manufacturing wave energy machines. The manufacturing process of wave energy machines involves several key steps, including design, material selection, fabrication, assembly, and testing. Let's take a closer look at each of these steps. Design. The first step in the manufacturing process of wave energy machines is the design phase. This involves developing the specifications and requirements for the machine, as well as designing the components and subsystems that will be used to convert the kinetic energy of waves into electricity. Material selection. Once the design phase is complete, the next step is material selection. This involves selecting the appropriate materials for each component and subsystem of the wave energy machine, taking into consideration factors such as strength, durability, and corrosion resistance. Fabrication. The fabrication phase involves the actual manufacturing of the components and subsystems of the wave energy machine. This can involve a variety of techniques, such as welding, machining, and 3D printing. Assembly. Once the components and subsystems have been fabricated, the next step is assembly. This involves putting the components and subsystems together to create the final wave energy machine. Testing. The final step in the manufacturing process of wave energy machines is testing. This involves subjecting the machine to a series of tests to ensure that it meets the specifications and requirements that were established during the design phase. Manufacturing wave energy machines presents several challenges and considerations that need to be addressed. One of the key challenges is the harsh marine environment in which the machines will be deployed. This can lead to issues such as corrosion, fouling, and damage from waves and currents. To address these challenges, wave energy machine manufacturers need to use materials and coatings that are resistant to corrosion and fouling, and to design the machines in a way that minimizes the impact of waves and currents. Moreover, the manufacturing of wave energy machines also presents ethical considerations related to the responsible use of resources and the impact on local communities and ecosystems. It is important for manufacturers to adopt responsible and sustainable practices throughout the life cycle of the machines, from material selection to end-of-life disposal. Wave energy machines are an exciting and promising technology that can provide a sustainable and environmentally friendly source of energy. Here are some potential benefits and applications of this technology. Renewable energy. Wave energy machines can provide a renewable energy source that is available 24/7, unlike other renewable energy sources such as solar and wind, which are dependent on weather conditions. Energy security. Wave energy machines can provide energy security by reducing dependence on fossil fuels and imported energy sources. Environmental benefits. Wave energy machines are a clean and sustainable energy source that can help reduce greenhouse gas emissions and mitigate the impacts of climate change. Economic benefits. The development and deployment of wave energy